So in this video, we're going to look at an example of using a truth table to prove whether or not an argument is valid or invalid. So as you can see, this particular argument that we are looking at has two premises. The first one says P, the second one says P and not Q, and then our conclusion is Q. So as we know, the first thing that we need to do is create our compound statement, the one that we're going to put into our truth table. And we need to do that by putting an and sign in between each of the premises and creating an if-then statement. And what you can see is that we've done that here. Here is my first premise. Here is my second premise. I've put the and sign in between them and the brackets around them. And here is my conclusion. So what we're going to have to do is we're going to have to now go ahead and create our truth table. So to start, we know we're going to have P and we're going to have Q, and as a reminder, P is always set up as true, true, false, false, and Q is always set up as true, false, true, false. Now, just looking at our compound statement, we also see that somewhere down the line, we're going to need a not Q, so let's just put that in now while we have the opportunity. And so we're going to take everything in Q and negate it, and that is going to look like false, true, false, true. The next thing we're going to do is we're going to sort of tear apart this compound statement in pieces. What we see is when we look at the antecedent of our if-then statement, we see that we need a P. We have that already. But we also need a P and not Q. So the next thing we're going to find is P and not Q. And as a reminder, and is true only when they are both true. So understand that what we're looking at is this column here and this column here. And so we need both of them to be true. And we can see that happens here actually only in the second row. And so this one is going to be true and the rest of them are going to be false. Next, we need to look at the and sign in between the two premises. So we're going to look at P and not Q. So this time we're actually going to be looking at this column in comparison to this column. And again, we need them both to be true. And once more, the only time this occurs here is in the second row. So we've got false, true, false, false one more time. And now the last column that we're going to have to look at is the if-then statement. And I'm going to be a little bit lazy here and only write the arrow, not actually write out the entire compound statement again, but here are all of my premises. Here is my conclusion here. And remember, for if-then, it's if true, then false is false. So let's take a look at what we have. Now remember that when we are looking, we are going to be comparing this column, and we're actually going backwards in this direction. So if we're looking for if true then false, we're going this way. So what we're going to do is we're going to look in this direction. I'm just going to sort of highlight the ones that we're looking at. Here we go. We're going this way. And what we see is in the second row here, we have if true then false. So we know the rule for the if then is that if true then false is false. So this one is true. And the fact of the matter is, I don't even have to look at the other ones because once I have a false in here, I know this cannot be a tautology, and so my argument, therefore, is invalid.